we use the test. So let's review the test. So this is the unit test. So I'm going to do split vertical. And we want to test the add. So add David, Edward, George, right? Now we want to assert. First thing is not empty. And assert also, we expect the result to be when we add David, Edward, George, this is adding as stacks. So George should come first, right? Edward and David. This is expected, and this is what it actually contains because we add to the list called toString. So let's look at our LinkedList again here. Look at toString. So I have to remove dot. Last time I do dot get pointer. Actually, it keep moving. It's 7.2 is moved to null when it's not equal to null. If you keep looking at the sequence again, so the current is one of this pointer where I initialize it, create it, and initialize to LL pointer, which is pointing to the same location, beginning of your stack or list here. And initialize list to get the elements, right? The values of each to return. But to iterate this, first, current.getElement is going to return George, which is why I expect to have George first, and then Edward. By current equals to current.getPointer, that means I move my current down, right? Current equals to, the previous one is current.getPointer, get this one. So now current move down, right? This line pretty much just do that. This current equals to current get pointer. And then loop back. Current not equals to null because current is Edward. Then it's going to get element Edward. Appending space and move current again. Current equals to current get pointer. It meaning that this current dot get pointer will return David, right? Will return David and move this current equals to David, right? So it's moving down again, right? So now we go back. Current not equals to null. Current dot get element, which is David, and appending space, right? And then do again current dot get pointer. Current dot get pointer is going to point to this mean null. So it's going to move down and point to null, right? Pretty much null right there. If I can just say that. And it's just moved down and point to null. Meaning that come back while current not equals to null is going to do that, which is going to exit the loop because now current is null. Return the list, which is print out George, Edward, and David. That's what we expect to see: George space, Edward space, and David space at the end, right? Let's test. So it passed, it's going to show greens. So that means this is exactly right. If you want to print out, we can just, if you want to see the actual list, just call list. It will instance will call toString method, and it's going to run and show the exactly right pass green and George, Edward, David. That's how we use unit test to test your. You have to test all the method or each method that you have. Okay, to make sure it passed. Okay, so Now, when you turn in the work, what I want to see is I only want to look at the output here with all the greens. Add green, right? If I want to test is empty, I can run at the class level. It's going to be green add green is empty. When I click, I see the result of add is empty. I see system.out, right? I see the result because you add. I see that, oh, that's correct. That's how you do push. George should come first. So if one of this is red, you lost a point. And of course, you may just always say assert, make it to true, then make it always green. I look at your code and look at what you print out here to verify that it passed all the tests. So that means you have to make sure it works. All right, so now we understand the basic of writing a data structure and test that, right? So now we can see this is when you add, and we can remove too, right? I'm going to create a new method. Say when you remove, right? Of course, this method you're supposed to, when we do data structure, you're supposed to implement an interface. An interface is going to fill up like I showed you last time on iStack, right? And then when you do stack, it's going to fill that method for you, right? Pop top, which we have push and so on, right? Like last time, I think we did the bound stack with array, right? So that's supposed to be too. Now, if I want to create a list interface, so I'm going to create class interface, right? So let's talk about let's pick up thing we have. I just showing you the order list, but I'm not going to create interface for order list yet. I just create interface for just simple list to use in our linked list here, which gonna have add, remove, contain, is empty, size, get, to, string, and so on here, right? So let's name it. Again, we have I represent interface, right? I list. Public void add. Now when we remove, we want to return, make it as a generics, right? So it's going to return an object that you remove back. So we pass in what you want to remove. The elements that you want to remove, return it back. Contains is Boolean. It's going to say either true or false, right? If it contains this E element. Is empty, same Boolean, right? Is the list is empty. Size is going to return an int. How many elements are there, right? In the list. Get you want to get the element. This get not remove, right? Remove, you remove and return. Get, you not remove, just return. Right, but the elements stay in the list. ToString, yeah, ToString is common. I'm not going to put in the interface. Alright, so these are the iterator. So let me create an iterator interface then. Iterator II, an interface for iterator, which has reset, which is Y. Let's remove everything out of the list, reset it, right? Has next, get next, and this is going to be an E. Get next pretty much just get the next one from the current elements back. Like get the current one. Get next, get the next one. Right. Next out of the elements. Right. We want to check up first that if it has next. If it has next, then we can get. Otherwise, we cannot get. So that's why we have to check has next first to see if this element is the last one, right? It's return either true or false. And these are the iterators. So we make it as an iterator class, I mean interface, and then the list just extends the II iterator, right? Now, these are interfaces for the list, which we can just implement, right? The list. And then we're gonna add an implemented, right, methods. So in IntelliJ, do alt enter. It's gonna pop up, and we might just need to add them. I may not do it in the right location, or actually it did right. Okay. Oops. Let me do one more time. Implements the list E. L enter. Oops. L enter. Okay. Now we just need to. We already have add. The reason that why we still have it because I didn't have interface earlier, so I didn't have the keyword override. The problem is our interface is not correct. When you add, you're supposed to pass elements to add. So let's fix that. Okay. So that's how you do, right? You implement the interface first and then start to implement your code, right? And you may do like, so we're gonna tackle the easy one first, size. Okay, just to show. So we're gonna make private int count initialized to 0. Whenever you add one more line, count plus plus. Whenever you remove, count. We didn't implement that yet, right? So count minus minus, return, count, and we're done. 20 seconds. So we have to make sure we handle exceptions too. Our interface here, we didn't do that yet. So we have to go back to the interface and make sure that throws and last time from previous video we have empty list exception.